Oh, you can turn on the projector to that. Now, strange thing happened as I was shutting down the last class. It wasn't receiving stuff from the computer anymore. I hope it'll be now. Otherwise, what a pain in the neck. While we're waiting, we are recording, so I'm going to go on and go over some of these announcements. I know that none of you I've asked before are graduating this term, but if in case you do know somebody who is, tomorrow is the last day to get for people who are graduating this term, I mean finishing, getting their degree this term, there's at least 2 scholarships available. UAB and University of Alabama at Tuscaloosa have presidential scholarships. Everything has to be in by tomorrow. So if you know of anyone graduating now, let them know that as well. Now, the 2018 Talent Development, see, for some reason, it's not picking up. It says no signal. And I don't know why that's the case. Ah, there we go. There, got it back. All right. The 2018 Talent Development and Innovation in Sciences Summer Internship Application Deadline has been extended to Friday. Okay. Now this is from the QEM, which is Quality Education for Minorities. They emphasize both HBCUs and tribal colleges and universities, that would be Native Americans. But there's these internships, I'll just tell you a little about them. They're called TDISs, Talent Development and Innovation in Sciences. 10-week paid. They pay you for these internships. It's not a freebie. They pay you. Includes housing. You don't have to provide your own housing. They will provide the housing in the Washington, D.C. area, conducting research projects with the National Science Foundation, so it's really good stuff. They are also engaged in a variety of professional development activities and can receive additional support once the summer's overtime from QEM to attend conferences, workshops, and trainings throughout the academic school year. So it's really a very, very good deal. And they say, please encourage your students to learn more and apply. So even if you're not interested, you may know of someone who is. I've got the information here. You're certainly welcome to look at it. There's also, you see that NCAS up on the wall there? That stands for NASA NASA Community College Aerospace Scholars Program. That's what it stands for. I have trouble remembering that. And anyway, they sponsor opportunities to participate. You need to be a U.S. citizen, at least 18 years of age, high school graduate, registered in a community college, and I think they got these dates wrong. They say fall 16 and spring 17. I think it's fall 17 and spring 18 semesters. During the application process, have at least a cumulative of 9 hours in the STEM discipline. It would be your math or sciences. Able to commit to working with NASA, starting with a 5-week online course, ending with a 4-day residential experience. I think that might be at Johnson Space Center in Houston. I'm not sure, but I believe that's where it is. And the deadline for this, actually they say is tomorrow. I thought this was the next day. Okay, so it's tomorrow. There's more information here. I'll be glad to share it with you, including, and you'll see the same logo here, NCAS. It tells you a lot more about it. There are some online information sessions if you want more information first. The first one of these is March 1st, tomorrow, 5 to 6 Central Time. And it tells you how to log on to that. So if you're interested, here's the information. It's up here. Now, here's something a little bit different. You know, right next door to us here is the Mill South building, okay? You know, this loop that goes all around the A building here and B and a couple of other buildings, mostly A and B, okay? That loop, on the outside of the loop that way is the Mill South building, and that's where our one-stop career center is. And they are taking applications for the job fair, and this is, the company is First Call Quality, or First Call Quality Services. They're based out of Indianapolis, Indiana. They're looking for quality inspectors who start at $11 an hour, team leaders who start at $13.50 an hour, and they'll be here, I assume, evaluating candidates next Tuesday, March the 6th, at the One Stop Career Center just next to us here in the Mill South building. The time will be from 9 in the morning until 1 in the afternoon. That's next Tuesday. Benefits are available in addition to those salaries. Benefits are available. Applicants must have a clear background check, driver's license, high school diploma or GED, and here's a little bit of a kicker, but it's not a big one. Automotive manufacturing experience preferred, okay? But if you don't have any, you can still apply. If you have questions, two of the ladies who work over in the Mill South building, Brenda Thomas and Dorothy Henry, have numbers for them, so you're welcome to give them a call and look into it. Mr. Rassi is still building her math team, and they have practices most Fridays at noon on the Birmingham West campus in the Science Building, room C100. Not this Friday, though, not day after tomorrow. She's going to be at the same meetings I'm going to be in Jasper, Alabama, so she won't be there for that. They are meeting also on Mondays at 3, same place. All right, this is David, right?
Yes, sir.
Yeah. All right, good deal. Anyone else come in since we called roll? I think I've told you before about the various tutoring opportunities on both campuses. If you need more information about that, I've got it up here. Today, as soon as this class is over with, I've got to book it to the Ethel Hall auditorium or conference room, I think it is, because there's a meeting going on now, and I told them I got class, I can't be there, I'll be there after 3:15. So as soon as this class is over, I'm heading that way. And that should be over sometime after 4, so if you need to see me, hang around till a little after 4. I should be back in my office then. Okay? They're meeting us to death. Okay, we have another meeting tomorrow from 2 to 5. However, I can't be there as late as 5 because I've got to leave to go to Jasper, and I need to leave probably by 4 o'clock because I'm supposed to meet some people in Jasper between 5:30 and 6. So with rush hour traffic and all that kind of stuff, I'll probably have to leave at 4. So once I leave the building here to go over there at 2 o'clock, I won't be back in the building. And then I'll be at neither campus on Friday because the meetings are at Jasper on Friday. Okay. And for none of you are graduating, but if you know someone who is, there are graduation meetings Monday at 6 o'clock on the Birmingham campus, Tuesday on this campus, Ethel Hall Auditorium at 1:30, and then Wednesday back on Birmingham campus in the ACAT building at 1:30. All right, did I get everybody present who on the roll who's here now? Okay. I think we're ready to start the slideshow. Believe we got finished with example 2, and this is where we were beginning. Any questions on anything we've covered so far? Because we may run a little out of time at the end, let me go on and tell you something now. I pulled off what I'm using for quizzes for you are the unit tests from last time, or sometime in the past. They had them on the website, a Blackboard thing for math resources. I pulled it off and then was a bit surprised, but I think it's not a bad thing. Way longer than I make a quiz, okay? 20 questions, okay? But they should go pretty fast. The first 2 questions are a lot like the questions you had on the last test. Well, not possibly the last test on those last quizzes as well, okay? The reason for that, the final exam is comprehensive. So I think they always pull back and do a few of the questions you've had before just to keep them on your mind. Okay, those are solving some problems, 2 of those. Then solving some equations, there's 4 of those, like you did on the last test. And then solving formulas, like you did on the last test, there's 3 of those. So the first 9 questions are review from the last unit. Beginning with question 10, then the stuff we've done in this chapter, chapter 11. So and they don't do a good job of using the pages well. The first page is fine. Second page has a lot of space at the bottom. They could have put question 16 at the bottom, but they didn't. And then they could have put question 17 after this one. They didn't. And then they could have put 18 after that one. They didn't. And they could have put 19 and maybe even 20 after that. So it's a lot of extra pages, but it was in a PDF format that I couldn't adjust. I couldn't correct because I don't have writable PDF rights or whatever you would call it. All right, Greg Joyce here. So I'll be passing out those at the end. I know you're in. There you are. So you need to get those in fairly soon. We aren't going to finish this chapter until, I guess we could finish it today. I kind of doubt it. I imagine it'll be Monday before we finish the chapter, what we're going to cover in the chapter. And then, so sometime after Monday, we'll have the test on chapter 11. Now, when I make out the test for 11, it's just going to be on 11. Okay, it won't be questions from before, but that's covered in your quiz, so you've got this. All right, any questions? All right. Now, don't leave today without your quiz. It's a very long quiz, but it shouldn't take you that long to do. All right, we have done this before. This is sort of summarizing what we're doing. Graphing a line, given its slope, and any point on the line. Okay? So, they're starting this with graphing a line using the slope and the y-intercept. Up here they say any point on the line, or a point on the line. Now they're talking y-intercept. That's even easier. Okay? So what do? Whatever that equation is, however complicated or convoluted it looks, what you need to do is first write it in slope-intercept form. How do you do that? Y is equal to mx plus b. So how do you get that? Solve for the y. Okay, if you have y's over here and y's over here, x is either place or whatever, numbers all over the place, group all the things together, get all the x's on that side, the y on this side, all the numbers on this side, isolate the y, and you're going to have it. What is the slope? It's what? Okay, it tries over run, but in that equation form, when you have a slope-intercept form, where do you find the slope? X. It's the coefficient of the x. And the y-intercept? The constant number at the end. Okay? So, that's what you'll do. They say, first identify the y-intercept. That's the first thing you graph. It's hard. You can't graph a slope, you know. You have to have a point to graph. So the first thing you do, identify the y-intercept. Like we just said, when you isolate the y equal something with x in it, the coefficient of the x is the slope. Don't worry about that yet. Whatever follows that, that's the y-intercept. The y-intercept is 0, that b, whatever the b is. Okay? Graph that point. How do you graph it? Where is it going to fall? Y-intercept? Yeah, up or down. The y-axis. That's what it's intercepting. It's intercepting the y-axis. If that b is positive, you'll be somewhere up here. If it's negative, you'll be somewhere down there. 0 is the x-coordinate of anything on the y-axis. So that's why it says 0b. So graph it, identify, graph that point. All right, then you find the slope, and where do you find the slope? The coefficients of the x variable. Okay? Now, if that coefficient is just a number, 7, put it over 1. That means it goes up 7, rise for every 1 that it goes over. If it's in a fractional form, then numerator is the rise, denominator is the run. Okay? Now, if that fractional form is negative, that means it's not a rise, but a fall. So it goes down for every. The run is always considered positive. Until you plot in all the points you want that way, and then you can reverse it. If it's negative, make it a positive rise and a negative run. And that way you're going to the left. So you can use both of those techniques there. It's always rise over run. What if that coefficient was a decimal? What would you do then? Change it to a fraction, exactly. If it's 0.7, 7 over 10. Rise of 7 for 10 run. Okay? So however it is, plot that, do that. Use the geometric interpretation of slope, rise over run, to find, I don't say just another point, a series of points by counting from the y-intercept. Then join the points, I do more than 2, with a line to obtain the graph. Okay? We talked about doing it. I don't know if we've actually done it, but it's pretty straightforward. Here we go, jackets. Okay? I went to Georgia Tech, there it is, yellow jackets. Okay? If this is example 3, hey, can you believe it? The one in the book is the one on the slide set. All right, first time I think all term. Okay? How would you graph that? Where would you begin? Let me get my pen set up. Say again? Okay. It didn't take. There we go. All right. Let me tick off a few points here. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5. Negative 1, 2, 3, 4. I hope I got enough. So where do we begin? On the y-axis. There's negative 1 right there. What do we call that point? Y-intercept. And that y-intercept, by the way, is 0, negative 1. The y-intercept, first name, first coordinate is always 0 because it's on the y-axis. Okay, and then where do we go from there? What do we consider next? Yes, the slope is 2 over 3. 2 represents the rise, so that's 2 up for every 3 to the right. Right there. Then do another 2 up and another 3 to the right. Somewhere about there. I think I'm running out of room that way, but you could go down 2 for 3 to the left. That's also rise over run. It's fall over a negative run, okay? Yes? A little louder, I can't hear.
At the same point, you're just plotting it out where it's supposed to go.
Yeah. They said just do 1 point. I say, why don't you fill the graph space you have with them? That way you can see if you're doing them well. And the reason I said you can go down in this, because negative 2 over negative 3 is also 2/3, right? So, yeah. So that's as many as I can get in. Now, see, if I have more than 2 points there, I do a little bit better job of, no I don't, of connecting the dots, okay? It's not very nice, okay? Make fun of me, I don't care, it hurts, but I can live with it, okay? All right, any questions? They just plotted 2. They plotted y-intercept in 1. Plot as many as you can, then connect the dots. Make sense? Any questions on that? Okay, both of those pieces of information, vital. Y-intercept is where you begin. Slope tells you where to go from there. All right. Now, in your text, there's a B one. Oh, wait, I forgot. Same as in the book, so let me erase this ink and see how they did it. Same as before. First, identify the slope, 2/3, the coefficient of the x. See what goes in front of the x, that's the slope. And then the y-intercept is 0, comma, whatever follows the x. And you get it in slope-intercept form. That would be 0 minus 1. What you plot first is the y-intercept. You've got to plot a point before you can deal with the slope. So the y-intercept is 0, 1. Graph that point. There it is, a little light blue point here. Okay, and then where they went from there is the slope is 2/3, rise over run. So rise of 2, run of 3. Okay, run to the right of 3. You can't go any more because you're off the graph. But you could have done one more this way by going down 3, down 2, negative 2 over left 3, negative 3, negative 2 over negative 3 is also 2/3. So that would have been another point. And then connect those. You'll see them do it. The slope is 2/3. That represents rise of 2 for run of 3, or rise of negative 2 for run of negative 3, either one. So count up 2 units, to the right 3 units. That gives you a rise over run. There's the up 3, up 2. There's the right 3. That point right there is your next point on the graph. Little blue dot. Okay? Now they didn't do the other one, but I showed you can do the other one too. Go down to left 3. That gives you another point on that line. Connect the 2 points. Connect the dots. Now, looks like to me they had trouble connecting the dots too. This one's a bit low here, and that's a little bit high there, but you get the general idea. Okay. Any questions on that? Pretty straightforward. All right. Obviously, they aren't going to do the B one. They don't have the B one here, so we'll back up and do the B. All right. Yeah. All right. Okay. I know you're in. There you are. Okay. All right. Anyone else come in since I called roll? Okay. Now, the B part here is this one. 3x plus 4y is equal to 8. Okay? Now, most of them they set up like this. If you can, it's not a bad idea to do the intercept method. If you set x equals 0, what do we get? Nope. Nope. 2. 4 times 2 is 8. Okay? So that means when x is 0, y is 8. Y is 2. You got me doing it now. Okay, y is 2. Okay? Guess what you just found? The y-intercept. Okay? Now that's not how they're suggesting to it, but I'm just telling you another way. The trouble, though, is if you try to do the y-intercept, the x-intercept, where y is 0, what do you get there? 8/3. That's hard to graph. So if that worked out well, and I'll tell you what will make it work out well. If this number is a multiple of that number and that number, then the intercept method is a really easy way to do it. This was a multiple of this one, but not a multiple of that. So intercept method isn't so good. So let's go to plan B. Even though we already got the y-intercept, what would plan B do? What would you do first? No, not yet. Solve for y. Remember? Yes. So what would you do? How? Throw it away. Erase it. Subtract 3x from both sides. Okay? That gives us what? 4y is equal to negative 3x plus 8. Now what? Now we do your divide everything on both sides by 4. Okay? What does this give you? Y is equal to negative 3/4 x plus 2. What does that tell you? What information do you glean from that form?
It's a negative slope.
Okay, the slope is negative 3 over 4, and y-intercept is what? 0, 2. Perfect. Where do you begin with the graphing? Y-intercept. So how do you find 0, 2? Say again?
Go up 2.
Okay, just say 2, not yours. Okay, got it. Okay, there's up 2. Next?
Down 3.
For every 4 to the right. So down 1, 2, 3, 4 to the right would be right over there. Now they would stop there. I suggest doing what?
Another point.
And how do you do that? This time just put the minus with the 4 and not the 3. So you go up 3, 1, 2, 3 for every 4 to the left. There you go. Negative 4 would be 4 to the left. Now you can connect the dots. Ooh, I can't. You can. Okay, there we go. Something like that. See if I can clean that up just a little bit. All right. It's a little better, not a lot. Okay. See how that works? And sure enough, a negative slope. Not quite a one-to-one slope, a little bit shallow of that, but not too far off. Negative 3/4. Does that make sense? All right. Now, okay, yeah, we already did that. All right, now, the next is writing a equation given a slope and a point. This time the point will not necessarily be the y-intercept. In this case, we use a form, not the point-slope form, I'm sorry, slope-intercept form, but the point-slope form. So all you have is a point, x1, y1. That means that neither of these might be 0, that one of them could be 0, whatever. They both could be 0, but they don't have to be. It's just any old point, x1, y1, that you know is on the line. Okay? And then they give you this form. Now, do you have to sit down and memorize another stinking form? Not necessarily. Where do you reckon they got that form? What does it look a little like? Say that again? I think you're talking about the one I'm thinking of, and that's called the slope formula. What is m? y2 minus y1 over x2 minus x1. There it is, isn't it? Now this is if you knew 2 points and you're calculating the slope, right? Now that same form works if you know the slope but only 1 point, x1, y1. To get this to work, all you do is lose the 2's. Oh, that almost rhymes, doesn't it? Okay. And then multiply both sides by x minus x1. And you have, get my pen back, if you multiply both sides of the equations by x minus x1, now rearrange it a little bit, you get y minus y1 is equal to m times x minus x1. So yeah, if you remember what the slope formula is, you can always get the slope-intercept formula. Point-slope formula. Al is here. All right, good deal. Anyone else come in since the call draw? All right. And then all you do is plug and chug. Okay? If you know a point, x1, y1, and know the slope, m, you can write the equation of the line. Done. Okay? Let's see that. Anyone still need that up here a little bit longer? Okay. If I ever get to flashing these things too fast, stop me, slow me down. I'm not in any huge hurry. I just get to rattling off at the mouth. I've got to make a 30-minute presentation at the meetings on Friday. Right now I've got enough slides to go an hour and a half, I think. So that's what I was doing before class, was trying to figure out either how to say this really fast or cut out some stuff. So I keep wanting to add more, so it's a permanent problem with me. Okay, everybody got it? All right. So let's do, where in the world did they get example 6? Okay. Let's us do example 4. Let's see if they, no, they're not the same. Okay, example 4 in your text is graph the line passing through the point -2, 3. I'm not going to do that one. With a slope of -4. Okay. Now, all they're saying right now is graph it. Okay. So let's do our axes here. Do 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. Positive 1, 2, 3, 4, 5, 6, 7, 8. And negative 1, 2, 3, 4, 5. Okay? We first graph the point -2, 3. How do I do that? A little louder? My hearing's so bad. Say it one more. Left 2, up 3. Just, all right, there's 3. Okay, and now you do -4/1. So down 4, 1, 2, 3, 4, and right 1. There it is. You can do it again. 1, 2, 3, 4, and right 1. Okay? Or you could have gone, put the minus with the 1 and not with the 4, and that would have been up 4, 1, 2, 3, 4, and left 1. Put the minus over there, and this gives you approximately that line. Now, we didn't write an equation for it. All we did was graph it. But since we're here and got it written on the board, why don't we do an equation for it? Since you're given the slope and a point, what equation might you use? What form? Point slope. And how does that go? Y minus y1 is equal to, a little louder, m times minus x1. Okay, now remember, the subscripts are actually points. The variable without the subscript is a variable. Just leave it alone. Don't put anything in its place. And we know a point, and we know the slope. So you tell me what to plug in where. What do we plug in for y? Nothing. We write down y. Okay? Trick question. Minus, we put minus. Where do you get that? y1. This is x1, y1. That's your point. So what's your y1? 3 is equal to, okay, you don't have to put the over 1, and it's a -4. Minus 4 times, what do you put for x? You put x. x1, you put the -2. So it's minus a -2. Do you see that? The x's and the y's without the subscript, leave them as x's and y's without the subscript. The ones with the the subscripts are your things from your point. That's where you plug in the point. All right? What do we do next? and we can take as many steps as we want. Let's just leave the left-hand side alone. Call it y minus 3 for now is equal to. Let's leave the minus 4 alone for now. Okay? What is x? X is x. Minus a minus 2. What would that be? Plus 2. Okay, now let's leave the left side alone again. Y minus 3. And what do we do with that minus 4? Okay, you distribute it across the parentheses. Negative 4x. Second? A little louder? Minus 8. Perfect. And now what? Okay. Okay, time out. Okay. Before you answer any further, this example 6, which we're not doing, but let's use their instructions. Give the final answer in slope-intercept form. Tell me how slope-intercept form looks. Y is equal to mx plus b. So to get there, isolate the y. So what do we need to isolate that y? Get it by itself. Just a naked y there, huh? Add 3, is that what I heard?
Yes.
Good idea, okay? Let's add 3 to both sides. All right, and what does that give us? Y is equal to negative 4x minus 5. And guess what, team? Your y-intercept is going to be?
Negative 4.
No, your slope is negative 4.
Negative 4. 0, negative 5.
That's your slope, okay?
0, negative 5.
0, negative 5, and look at there. There's 0, 1, 2, 3, 4, 5. Bingo! I mean, we can't say bingo in Alabama. Okay. So, there's your y-intercept right there. How nice, huh? Okay? See how it works? Okay. Let's continue and do example 5. Okay? This will be from the text. So I'm going to erase this on the slide. And example 5 from the text says, write an equation in slope-intercept form of a line having a slope of 4 passing through the point 2, 5. Okay? They didn't say graph it, so I'm not going to graph it. I just want the equation. What does every equation have to have? An equal sign. Generally, you'll have 1 or 2 variables, x or y or something else, and it'll have a few numbers scattered around. Okay? So how would we begin if we know the point and a slope? Second? Okay, and what's the equation is that? Y minus y1 is equal to m times x minus x1. And what do we put where? Y stays y minus 5, that's your y coordinate of that point, is equal to 4 times x minus 2. Perfect. Now what do we do? Yeah, distribute the 4 across the parentheses. That gives us y minus 5 is equal to 4x. Second? Minus 8. And now what? Because we said get it in slope-intercept form. Add 5 to both sides, isolating the y. And that gives us y is equal to 4x minus 3. Okay? Now, notice here, the slope was 4 there, the slope is still 4 here. You should never change that, okay? Number 2, now we know not just the point 2, 5, we know another point. What point would that be? 0, negative 3, because that's your y-intercept. The x is always 0 for the y-intercept, and the value is negative 3. That should be good deal. And that's what the book got, good for them. By the way, every one of these examples on the side and the margins, you have other examples similar. As soon as you get out of class and have a moment, try to do those. Then do the homeworks later, okay? Anytime you want to. But try to get those done as soon as you can. All right. Now they get around to telling us point slope form, which I think we've already done, right? That was on an earlier slide. Yeah, there it is. Okay, that's at the bottom of page 767. Now we get to example 6. Okay, let me erase this. Any questions before I do erase it? Got it? Okay. Example 6. Find the line passing through, oops, wrong one. Okay, you want to do the one on the slide first, and then we'll come back and do the one in the book, or one in the book first, and we'll do the slide. I don't care. Do this one? Okay. Find the equation of the line through the point 3, 2 with a slope of 1/3. So how would we start? Or would we start? Or do we just sit here? Let's start. Huh? Y minus Y1 equal M, I can't write, times X minus X1. Because we have a point and we have a slope. So use the point slope formula. Okay? And what do we plug where? Y minus 2 equals 1/3 times X minus 3. Okay? What would we do next? Yeah, distribute the 1/3 across, so leave the Y minus 2 alone for now. Is equal to 1/3 X. So that's the denominator, that's the numerator. If the 3 on the outside, that would be a minus 9. 1/3 on the outside, multiply 1/3 times minus 3. -1. Okay? Yeah. If you had 3 pies here, and you take 1/3 of them, how many pies do you take? 1 of them. Yeah, because we leave 2/3. I'll take all 3. No, I'll take 2/3. So that's what you're doing when you're multiplying. Okay? Now what? Add 2 to both sides, and that gives you 1/3 X plus 1. What does that tell you? 0, 1 is your y-intercept, and 1/3 is still the slope. If it was more, you can't change it. It stays the same. Okay? Now you have 2 points, you have a slope, you can plot away and knock yourself out. Okay?
Can you show me again how you get that -1/3?
Okay? All right. Let's take this and do, let's be 1/3 X, 1/3 times X, minus 1/3 times 3. Right? You're distributing the 1/3 inside. Or you could put plus with a minus 3, whatever. You just have to have one. Okay. Now, 3 is the same as 3 over 1. And what is 3 over 3? When you're multiplying fraction forms, multiply numerators, multiply the denominator. Yeah, 3 over 3 is 1. There you got it. Okay, good deal. Excellent. Good question. Okay. Any others? Great question. All right, let's see if they graph this. Do they? Oh, wait. Is it all right for me to erase this, or you need to write some more?
Yes, I'm fine.
Everybody got it? Okay. All right. Now, so use the point slope form. Yeah, great idea, because they gave us a point and a slope. Here the M is 1/3, that's the slope, and the point X1 is 3, Y1 is 2. They wrote it out that way. If that helps you, write it out that way, okay? Here's your point slope form. Y minus Y1, which is 2, is equal to M, which is 1/3, times X minus X1, which is X minus 3. Okay? And then they just didn't They didn't explain any of it, but y minus 2, that just came down, is 1/3 x minus 1. I just wrote it down. That's 1/3 times 3 is 1. So 1/3 times minus 3 would be 1. Okay? Make sense? Let's see. Do they graph? Oh, no, not yet. They got to add 2 to both sides. I forgot that. And that gives you y is equal to 1/3 x plus 1. All right. No, they don't graph. Okay. Now let's do example 6 from the text. Write an equation of each line. They're going to give us 2 of them. Give the final answer in slope-intercept form. That's my favorite form. And the first is a line passing through -2, 4 with a slope of -3. So how would we do that? Help me, help me. Y minus 4 equals -3 times x, second, +2. Minus a minus makes it plus, +2. See it? Okay, next. Y minus 4 is equal to -3x minus 6. Excellent. And then add 4 to both sides. And what does that give us? Y is equal to -3x minus 2. What does that tell us? A little louder.
-2 is the y-intercept.
Okay, 0, -2 is the y-intercept, and slope is still -3. Yes, that checks. Okay, y is equal to -3x minus 2. Question?
On the second part to the equation, how come -6 is not positive?
Negative what?
6 is not positive.
Okay, because you're distributing the -3 across the parentheses. That's -3 times x is -3x. -3 times +2 is negative. Perfect. Good question. Excellent question. Okay. We got it. What they got it. Okay. Ready for the B part? Is it all right to erase this, or y'all still writing? Erase? Okay. All right. This time, the line passing through 4, 2. I'm being really lazy. With a slope of 3/5. Really lazy. Okay. So what would we do? Y. A little louder. -2 is equal to 3/5 x minus 4. Okay? I can tell this one's going to smell a little bit, right? What would you do next? Y minus 2 is equal to 3/5 x. What's this? Help me, help me. -12/5. Remember when we were multiplying, we multiplied numerators, we multiply the denominators. -12/5. Okay? Sort of a big boo hiss here, but we still got another step. What's that? Add 2 to both sides. Now I'm going to do something a little bizarre here, maybe very bizarre. Since this number is in fifths, okay, I want to add 2 in fifths. How many fifths is 2? 1/5 is 2. Okay. If you give me $2, I'll give you 1/5 of a dollar, and we'll be even, right? Oh no, okay, he's not going to buy it. Okay, sorry about that. How many fifths is 2? 10, maybe 10/5. Okay? So let's try that. Is 10 over 5 the same as 2? The same as 2? I can't write. What I'm doing is just cutting out a step here, but I'm trying to make it make sense. Is 10 over 5 2? Yeah. Okay. So you can add 2 any way you want to. I want to add it as 10/5. Right? So what does the left-hand side give us? Y. Why not? Is equal to 3/5 x minus 2/5. Okay? Now, I'm not about to want to graph that. Okay? Not in this form. Because then your y-intercept is 0 minus 2/5. And that's a hard thing to plot. So how I would plot this one was just start with the point they gave us. 4, 2, 4 to the right, 2 up, and then do your up 3, right 5, up 3, right 5, or down 3, left 5, down 3, left 5. Use that point and that slope rather than plotting from this form. Yuck, it's really nasty trying to find those fractions on your graph. So, hey, pay your money and take your choice. You already paid your money, so you get to choose which way you want to plot it. This is the simplest to write, but it's not the easiest to graph. That's the easiest to graph. Make sense? Let's see what they got in the book. Yeah, say again.
I'm sorry, you said 3 down. Did you say the 3/5? How did you graph it?
Okay, let me draw the graph and go with it. Okay. 1, 2, 3, 4, 5, 6, 7. Negative 1, 2, 3, 4, 5, 6, 7. Up 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. Okay? Now, rather than trying to graph from this one, which your y-intercept would be 0, negative 2/5, it would be somewhere about in there, and then you have to go up 3. That would be 1, 2, 3. You have to say 2/5. Yeah, it's just a pain in the neck, okay? So rather than do that, start with the point 4, 2. They gave it to you, said it's on the line. So we start with 4. 1, 2, 3, 4, up 2. That's right here. There's your point. Now from there, use your slope. Up 3, right 5. I can't quite get that on the thing. That would be up 1, 2, 3, right 1, 2, 3, 4, 5. Somewhere off the screen there. Okay? But since that's off the screen, what I think I'll do is go down 3, left 5. Minus 3 over minus 5 is still 3/5, right? So we go down 3, 1, 2, 3, left 5, 1, 2, 3, 4, 5. There's my second point. And we may even be able to do another one. Down 3 again, 1, 2, 3, left 5 from here, 1, 2, 3, 4, 5. Somewhere about there. Okay? And there then would be, something like that. That's my line, sorry. I don't draw very good lines. Okay? Sure enough, 3/5 slope, it's a positive slope, but not super steep. Okay? And it goes through that point. Make sense? Good deal. So sometimes slope-intercept, even though it gives you the most information, is not the easiest one to plot from. That would be far easier to plot from 4-2 using your slope. All right. That was example 6 in the book, and we already did example 6 from the slide set. All right. Now, objective 4, can I go on and erase? Okay. Okay. Oh, they have an example 7 here. I guess they just don't say anything about this. This time they're saying write an equation of the line through the points -2, -2, 4. Okay. And for -1, give the answer in slope-intercept form. Okay? So this is different from example 7 in the text. But this little objective here that they just sort of skipped over, they call AX plus BY equals C standard form. Okay? Okay, you can call it that, but guess what? It's not very useful form. I like slope-intercept, but if they really want something in standard form, you need to get it in that form. So let's go back a slide or two before we do what they said here. Let's go back a slide or two and see if we can get, say, this equation in standard form. Here was our answer in slope-intercept form. Y is equal to 1/3 x plus 1. Now that's not in standard form. What would be the first thing you would do to get it in standard form? What's the messiest looking thing about that equation? I know you love them, but the fraction. So how could we clear that fraction? Say again? I can't hear. Yeah, multiply by the reciprocal. What's the reciprocal of 1/3? 3. So let's multiply this by 3, this by 3, and this by 3. You got to do the same thing to every term on both sides, right? Got to be democratic about it, right? So that gives you 3y is equal to, and what's 1/3 of 3? 1. Okay, x plus, and what's 1 times 3? 3. Now to get this in standard form, and it really doesn't matter, I think I like having x positive, so let's subtract 3y from both sides.
It's division, not subtraction.
Say again?
It's division, not subtraction.
What is division?
So 3y, you can't subtract 3y.
Why can't I?
From 3y, it has to be division, because it's 3 times y.
No, I'm not solving for y. I'm trying to get it in standard form. Standard form is ax plus by equals c. That's what I'm trying to get it in. So I'm trying to get the x's and y's together on one side and the numbers on the other side. Yes? You could have subtracted x from both sides too. Is that what you said? Yeah. We'll do it that way too. Okay? So let's do it this way. This would give us a 0 here. 0 is equal to x minus 3y plus 3. Well, I don't want that 3 over there with x and y. I want it somewhere else. So what we'll do? Subtract 3 from both sides, and that gives you x minus 3y is equal to -3. Okay? Now, Greg Joy wanted to subtract x from both sides. So what I'm going to do, I thought I was going to do it, is erase this. Okay? And we'll do the Greg Joy method, which is subtracting x from both sides. Okay, and what does that give us? -x plus 3y is equal to 3. That is also in standard form. It's just that you're leading off with a minus. But you know, maybe leading off with a minus is better than having 2 minuses the other place. It doesn't matter. Because guess what? If I multiply this equation, everything on both sides by -1, that becomes a plus, that becomes a minus, that becomes a minus. That's exactly what I get. Yes?
That first approach, is that more of a mathematical thing, or?
Say that again, Mike.
The first one, is that, you guys do that in math, or is that more of a physics thing?
What?
Can you leave there, because they teach us not to leave anything on either side. Let's leave something on either side, you can't leave 0.
No, you could leave a 0 there. Sometimes, in fact, later on, when you get into quadratic equations, not in this course, but in Math 100 or whatever follows this, you will sometimes want to have a 0 on one side. Okay? And we can talk about that later. But most of the time here, we either want it in slope-intercept form or what they call standard form. To me, nothing standard about that. This is awkward form, okay? But it looks nice, okay? That's one form of standard form. That's the other. These are exactly the same equations because you can multiply this one by -1. Minus, plus, plus, and you got exactly that. So as long as you do the same thing to both sides, it's perfectly legal, okay? So that's, either one of those is your standard form. Now, I just picked out that one to show you how to get an equation in standard form. Frankly, I don't see why you'd ever want to, but if you did, that's how you do it. Okay. Now let's go back to example 7. You want to do the slide one first or the book one first? The slide, okay? Write an equation of the line through the points -2, 2, and 4, -1. Give the final answer in slope-intercept form. So we're looking for an equation, but I do know, but, I'd rather not use it. They haven't given us a 2-point equation. They've given us a slope-intercept form, and they've given us a point-slope form. But they haven't given us a point-point form, because most of the time we don't do that. So what can you get out of giving just 2 points? What you know you can get from that? Second? Okay. Not yet. We don't have a slope, but there's the key. Can you get a slope from these 2 points? Yes! So that's the first thing we're going to do. We're going to find the slope. And what is the slope? y2 minus y1 over x2 minus x1. And does it matter which one of these you use to be the 2 and which one you use to be the 1? Not a bit. So which one do you want to use to be y2? No. Because that's an x.
2.
You see? 4 is an x, xy. That's an x. You can't use that for a y. Don't.
-2.
Okay, -1 would work, or 2 would work. Okay. All right, we'll do it both ways. We'll first do this to be your y2. Okay? So this will be 2 minus what? A -1, because that's your other y. Over. If you use that to be your y2, you got to use the -2 to be the y1. I know you want to use the other one, but okay. -2 minus 4. And this becomes,
2.
second,
2.
2, something else. What's minus a minus 1? Second,
Plus 1.
plus 1 over
-6.
-6. Right? And what's 2 plus 1? 3 over -6. And what slope would that be? -1/2. Perfect. Now we have the slope. So now what can we do? Point slope formula. So what do you want to use there? How does that point slope formula go? Y minus y1 is equal to m times x minus x1. Okay? Plug and chug, folks. What you put for y? Y. Perfect. Minus what you put for y1? All right, a -1. Equal -1/2. You just calculated the slope. What you put for x? X. Good. Minus 4. Okay, good deal. And now what do you do? Y plus 1 is equal to -1/2x plus 2. Because negative times negative is positive. 1/2 of 4 is 2. Okay? Now what? Second? Subtract 1 from both sides, and that gives you y is equal to -1/2x plus 1. Got it. What does that tell you? 0, 1 is the y-intercept. -1/2 is the slope, but we knew that already. Okay? Now, Greg George, you want me to do it your way, choosing the other one to be the y2? It'll give you the same thing, because then you'd have a -1 minus 2, that would give you a -3, over 4 minus a minus 2, that would be 4 plus 2 is 6, -3 over 6 is still -1/2. So that would work. Now the question is, what if we would use the other point and not that point, we use that point. Would that have given us the same thing? Yes, it would. It won't look like it will till you get to the end and you get it. The same point. Doesn't matter which point you use as x1, y1, or x2, y2, but once you chose one of those coordinates, the others are fixed. You don't have any freedom to choose any more. And once you choose one point to put in there, put it in, you'll get the same answer if you put the other point. It will work. Okay? Let's see what the book got. Oh, no, this is this one. So let's clear this out of the way. Can I clear it now? Any questions? Okay. Let's see what they do. First, find the slope of the line using the slope formula. Good idea. M is equal to, and they did it, they did it the second way. Greg Joy's way. -1 minus 2 over 4 minus a minus 2. See, once they chose this to be the y2, then this has to be x2, this has to be x1, this has to be y1. Okay? They're all fixed. Once you choose that first one, but make sure it's a y. Don't choose an x and put in the y. That'll never work. Okay? But once you do, get it right, and this will be a -3 over 4 minus a minus 2 is 4 plus 2, which is 6. -3 over 6 is -1/2, same as we got before. Right? Now what do we do with that? Point slope formula. Now use either -2, 2, or 4, -1. It doesn't matter. And they chose 4, -1. Is that the one we used? I think it was, yeah. So, still works the same way. Y minus a -1, y1 here, we're using that one, is equal to -1/2 times x minus, this would be y plus 1, is equal to -1/2 x, and then -1/2 times a -4 is plus 2. Add or subtract 1 from both sides. Y is equal to -1/2 x plus 1. Boy, that 1/2 mixes in with that. Now, I really don't like the way they're writing this, because if I were looking at that, I would almost think this is -1 over 2x. That's not a good way to write. Be sure, if you can't tell, put parentheses around it or something, because that is sort of confusing the way they've written it there, which is also sort of confusing up here too. Okay, so be careful. Don't get yourself confused if you don't need to. Okay. And you don't need to. Okay. Here, before you go, take a quiz. Okay? And you have till next Wednesday to complete it. But if you get it done sooner, you can. Let me remind you of this, folks. Because it is due. What's that? Okay. Because it's not due till next Wednesday. If you have any questions, work on them this weekend. If you don't know how to do some of these, find some like it in the book. I'll do anything like it in the book in class. What's that?
Can I get another one for the student?
I can't hear.
Can I get another one for the student?
For another. For whom?
There, Ben.
Oh, okay, yeah. Who's? Okay, I thought you said your tutor. Okay, okay. I thought no, they don't get one. Okay, okay, good deal. All right. That's example 7 from the slide set. Now let's go back and do example 7 from the book. Okay. Write an equation of a line passing through the points 3, 4, 3, 4, and -2, 5. Okay? Give the final answer in slope-intercept form and then in standard form. So they want it in both forms. So let's get started. What do we do first? Find the slope. And what is the slope? y2 minus y1 over x2 minus x1. And what do you want to choose as your y2? No. Wait. Here are my points here. Not those. I'll cross through these two paths. Huh? 5, okay. Y2 will be 5, so that will be 5 minus 4, perfect, over negative 2, excellent,
3.
minus 3, always a minus, a difference, right? Okay, and what will that give us? Five minus 4. 1 over negative 5. There's your slope. Now what do we do? Point slope formula. How does that go? Y minus y1 is equal to m times x minus x1. And what do we plug where? Y minus 4. You're going to use that as your 4. Good. Is equal to m. Oh, wait. We know what m is. What is m? Okay. Negative 1/5 times x minus 3. Okay. Because if you use 4 for that y1, you got to use 3 for x1. Okay, good. Now what? Y minus 4 is equal to negative 1/5 x. Say again? A little louder. Plus 3/5. Perfect. Way to go. Now what? Now we add 4 to both sides. But how might I want to choose to add my 4? Has so many fifths. Okay, here's what you do. Okay. 4 times 5 is 20. Right? Isn't that 4? That's how you do it. It's pretty simple. 20/5. Divide it and see. Yeah, that's 4. Okay. Now when you do that, what do you get? Y is equal to negative 1/5 x plus 23/5. That is in slope-intercept form, and by all means, I'm not about to graph it using that form. Okay? It's a nice form. It tells me what the slope is. What is the slope? Negative 1/5. Yeah, we found that before. What's the other thing tell us? 0 23/5. By the way, that's the same as 4 3/5. So that's your y-intercept. Okay? Now, how do we write that in what they call standard form, which is ax plus by is equal to c? Nope. Okay, yeah. Well, actually, the best idea, get rid of those denominators. We don't like them, do we? How do you get rid of them? Multiply everything on both sides by 5. Okay, so your left-hand side becomes 5y is equal to negative x plus 23. That I'd much rather work with than fractional forms. Add x to both sides. And what does that give you? X plus 5y equal 23. Your A is 1, your B is 5, and your C is 23. That's it in standard form, whatever they call standard form. Okay. And they wrote it in their book that way too. We didn't quite get far enough to do the summary. We will start there next time. Homework exercises here will be 1 through 4. Any of the ones 5 through 10. Any of the ones 11 through 14. No, 11 through 18. Any of the ones 19 through 24, any of 25 through 32, any of 33 to 42, Any 43 to 48? Any of 49 to 56?
Pages.
That starts on page 771 and going part of the way through 774. Okay? We'll pick up the rest of those next time. Okay? Any questions? Before you leave, get a quiz. Now remember, these are fairly long quizzes, so by all means, get started. Okay? There you go. Yeah, plenty of room to work on most of these. Okay? Pass one over. And you know. There we go. All right. Pass one over. You got one back. All right, I've got to book it over to the Ethel Hall building, but I'll be back sometime shortly after 4, hopefully.